Okay, excellent. Welcome everyone to this CIAQM webinar, the HVAC system's role in improving environmental air quality in buildings of all types. I'm delighted to be joined today by David Schurk, Director of Healthcare and Applied Engineering Markets for Global Plasma Solutions. He is joining us today from California, so thank you very much to him for joining us so early. So you're going to have a presentation from David, and then you will have the opportunity to ask questions. So please do submit these in the Q&A option at the bottom of your screen at any point during the presentation, and I will then read these out on your behalf later on. This webinar is being recorded and will be made available on the IES YouTube channel within the next week or so, so you can watch over it there as well. Thank you so much for logging in today. It's great to see so many of you here, and I'm now really pleased to hand over to David. Thanks, David.
Thank you very much. I appreciate that. It's an honor and a privilege to be with you here this morning here in the United States. It's 4:30 a.m. here. I think you're having your lunch there. So sit back, grab a sandwich, listen to what I have to say, and then let's open it up for questions and have hopefully some dialogue back and forth with regards to this topic. I am going to be talking about the HVAC system's role in improving environmental air quality in buildings of all types. And I think this slide is going to tee up our conversation perfectly moving forward. What you see in front of you is a young lady sitting in a room. She's holding her hand up in a sunbeam of light that's coming in through the window. And in that sunbeam of light is illuminated a whole bunch of stuff in the air that she's breathing. And she's looking at that thinking, I don't know what she's thinking exactly. I know what I would be thinking. Oh my gosh, what is that? I didn't realize all that stuff was in the air that I'm breathing. And it is, most certainly. And she's seeing it for the first time simply because it's illuminated. And what that stuff are all the particles that are in the air that she's breathing. And for a minute, I want you to stop and listen to what I'm going to say. And I'm going to say it twice. This is so important that you understand this specific point with regards to the air we breathe. Number one, everything in the air is a particle. I'll say it again. Everything in the air that we breathe is a particle. Even the atoms and molecules in the air are particles. They're very small. They behave differently than the larger particles, but they most certainly are particles, along with things such as various viruses, most certainly SARS-CoV-2 and its various variants are all particles, along with bacteria and fungi and smoke, volatile organic compounds and odors, products of combustion, skin flakes, metals, pollens, on and on and on. There are thousands of things in the air that we are breathing that are particles that are in the air there. And the scary thing is simply this: the vast majority of it is so small you can't count it when you walk into the room with a handheld particle counter that starts counting at about 0.5 micrometers. Let's take a look at some of the qualities of air, if you will. Number one, we spend 90 to 95% of our time indoors, in rooms such as what you might see here. In every cubic foot of air, there are some 18 to 20 million particles quite easily, and per cubic meter, between 630 and 700 million particles. As I had mentioned, the vast majority of those particles, some 95%, are smaller than 0.5 micrometers. That is very, very, very small. And again, as I mentioned, it is so small, number one, you cannot see it even when it's illuminated, such as the particles that you see in front of you here in this slide, and you cannot count it when you walk into the room with your traditional handheld particle counter. They are just too small to count. And last but not least, we breathe some 440 cubic feet or some 12,450 liters of air every single day. So you can imagine the impact that cubic foot or that cubic meter of air that contains all these particles might have on our physiological well-being. So at the end of the day, I think our mission in trying to create healthier, better indoor environments through cleaning the air is very simple. At least in concept, it's simple. It's not so easy to do. I'll talk about that moving forward. But at the end of the day, what we want to try to do is simply clear the sunbeam. We want to remove the particles that are there because everything in the air is a particle. And if I can remove those particles or remove more of them, and I can't breathe them, they cannot hurt me. And it's a relatively easy concept to understand. Now, I do want to say that what I'm going to talk about and what I think we want to do as HVAC and engineering professionals is do what I call balance the HVAC system approach. In the upper left-hand corner of this slide, I portray ventilation, right? The amount of hopefully fresh, clean outdoor air that I bring in from outside into the building to help dilute the pollutants of concern that are there, along with the number of air exchanges that I provide to the space to help flush those pollutants from the air. Very important. On the lower left-hand portion of this slide, I show filtration, the MERV efficiency of the filter that you install in the HVAC system, the efficiency specific to the particle sizes that are of concern that you want to remove from the air is very important as well. In the upper right-hand corner, I portray relative humidity. We have heard a lot of late with regards to relative humidity and its impact on our physiological well-being, that 40 to 60% sweet spot that is the best for us from a standpoint of our health and well-being may also have limiting influences on certain viruses and pathogens. They live longer and they're less infective or less critical to our health at those specific humidity ranges. So 40 to 60 RH in the building, if you can do it, is a great idea as well. And then in the lower right-hand corner, I have listed what I'll call advanced indoor air quality solutions that we will be talking about moving forward that, when applied, can make any of what I just talked about, ventilation, filtration, or relative humidity, singularly more effective, or perhaps combined more effective as well. And that's what I call balancing the HVAC system approach, because let's face it, as the COVID-19 pandemic progresses in time, there is a lower acceptance and adoption of control measures that impact on daily life, and therefore an increased need for effective measures that do not rely on human behavioral choices. Here in the United States anyway, social distancing is gone. There's no such thing. We're not wearing masks. We're not maintaining distances. We're not cleaning surfaces anymore. We're not doing any of that kind of stuff. I think, quite honestly, the last bastion of social distancing inside is simply going to be to clean the air. That is what is going to keep healthy people away from sick individuals that have expelled viruses into the air that we're breathing. And by cleaning the air, we hopefully will create an HVAC system that contributes to indoor social distancing, because there's a lot of things in the air that we shouldn't be breathing. It's not just SARS-CoV-2. I showed you a slide previously of what's there and how much, and it's scary and it's a concern, and we need to address that. Now, we have been led down a path over the last 2 years or so with regards to SARS-CoV-2 in the indoor environment and how it is or maybe is not being transmitted throughout buildings. The scientific community has told us that viruses in particular are what are considered fine and ultrafine particles, and they are so small, as I'd mentioned, in size and weight, that they are very difficult, if not impossible, to influence through air motion in the space and remove from the space, even in hospital operating rooms. This is a study on the left-hand side done in the American Journal of Infection Control, where they went into a hospital operating room, they did particle counts, and you'd think hospital operating rooms are relatively clean, and they are in comparison to perhaps the slide that I showed teeing up the conversation, the young lady sitting in her office or her apartment or her restaurant or school, or maybe even a healthcare facility. Hospital operating rooms certainly are cleaner than that, but there are still a lot of particles in the air. And the scientists determined through study that it doesn't matter how efficient the filtration is that you install in an HVAC system. If the particle can't get from the space back to the filter to be extracted from the air, the filter cannot be effective. And that seems to be an issue of concern with these very, very, very small particles as well. ASHRAE, the American Society for Heating, Refrigeration, and Air Conditioning Engineers, has come out with several peer-reviewed ASHRAE journal articles that have talked specifically about SARS-CoV-2 in the indoor built environment. And they have said with regards to SARS-CoV-2 that we have not seen evidence of its transmission through HVAC systems, although within a space. Air motion caused by HVAC components, as well as from fans, can be a factor. Other peer-reviewed ASHRAE journal articles have talked about the fact that the growing science around far-field aerosol transmission, the fact that they aren't leaving the space, they're too small to influence with air motion, essentially negates the need for induct or in-air system control technologies such as UV lights. And then the icing on the cake came on March 23rd of 2021, when the US Centers for Disease Control and Prevention updated their COVID-19 ventilation and buildings frequently asked questions, and that question was simply, can COVID-19 be transmitted through HVAC ventilation systems? And they concluded that while airflows within a particular space may help spread disease among people in that space, there is no definitive evidence to date that viable virus has been transmitted through an HVAC system to result in disease transmission to people in other spaces served by the same system. SARS-CoV-2 and other issues of concern seem to be originating in the space and remaining in the space as an issue of concern. Now, there's good news and bad news to that. We'll look at both, right? If you and I are in a space together and one of us is sick and the other isn't, and one of us is talking or coughing or sneezing or breathing or singing or whatever the case might be, and we're expelling viral material to the air that we're both breathing, if I'm the healthy individual, I may become sick based on that scenario, right? But the good news is simply that there is a lack of evidence supporting the fact that it is being distributed throughout the rest of the building through the HVAC system. So others that remain in other areas of the building may stay safe. Good news, bad news scenario. But the question then comes, the question that we have to ask ourselves is, what can we do? If I'm in a space with you and you're sick, or you're in a space with me and you're sick, we want to be safe. And we want to protect ourselves from all the other stuff that's in the air that we're breathing as well. So what can we do with materials that remain in the space to protect ourselves while we're in that space? And the answer is relatively simple. We need to treat the issues of concern in the space itself. That's what the guidance is telling us. On the left-hand side of this slide, I show in-space upper room UVGI or UVC lights. That's a technology that treats the issues of concern in the space. You typically have a box. It has a UV light in it. There's no fan. You mount the box up towards the ceiling and you direct the photons or the light energy up towards the ceiling itself. It needs to hit the ceiling. You don't want to direct UVC light down into the space where people are occupying the space. It can be detrimental to our health. But in this particular scenario, mounted accordingly, if there is air movement within the space, whether it be natural convection or mechanical air movement, it can take the issues of concern, if they're biological components, and it can circulate those over time through the fluence of light directed up towards the ceiling. And in time, it can help to inactivate or sanitize that air and make it cleaner. It most certainly is a product that can work in the space to help alleviate the issues of concern in the space. One device like this will typically cover about 200 square feet of surface area. So in a generously sized room, you may end up with 4 or 5 or 6 of these mounted along the outside perimeter of the building, all with the light shooting up towards the ceiling, all taking advantage of circulation in the space to help move the biological components through the light so that the light can inactivate them. I'll move to the center of the slide and I show in-space portable Hepa air filtration machines. It's typically a box with a fan and a Hepa filter. Hepa filters are 99.97% efficient at extracting the most penetrating particle size, 0.3 micrometers, which is about the size, the beginning size of a SARS-CoV-2 droplet nuclei. So effectively, it can clean the air. You would wheel these into the room, run the extension cord across the floor, plug it in, turn it on high, and allow it to circulate air within the space. And if the issues of concern can be brought from the space air back to that 99.9% efficient filter to be extracted from the air, it most certainly could be effective at treating the issues of concern in the space. And then on the far right-hand side, I show advanced indoor air quality technologies that could be applied as well, either in the space or perhaps in the HVAC system if they can reach out from there. And I show things such as needlepoint bipolar ionization, photocatalytic oxidation, dry hydrogen peroxide. We could look at other technologies as well. I will be talking about needlepoint bipolar ionization moving forward. Couple of reasons. I'm the most familiar with that, and it has 55 years of acceptance through the ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. Over 3 articles during that period of time. On the far left-hand side is an ASHRAE journal article that appeared in the 1966 ASHRAE Journal magazine talking about using bipolar ionization in a clean room. In the center is an article that talks about using needlepoint bipolar ionization in school applications. And on the right-hand side is a primer on bipolar ionization that I wrote that appears in the November 2021 ASHRAE Journal magazine. If any of you are members, I most certainly hope you either have read it or will read it if it's sitting in your inbox and to do. Let's talk a little bit about what ionization is. Ionization is simply an electrical charge that has been imparted to the atoms and molecules that are in the air. In the air you are breathing, most certainly. And they are imparted to the air through nature, through occurrences outdoors, such as, for example, lightning strikes. You can imagine the intensity of a high voltage lightning strike and its ability to charge with electricity the atoms and molecules that surround that bolt of lightning. And when you stop and realize that there are thousands of thunderstorms across the face of the earth every day, and literally hundreds of lightning strikes every second occurring across the face of the earth, that most certainly is a natural source of ionization to the outdoor air. As well, in the center slide, you see a picture of me standing by a waterfall near Charlotte, North Carolina, where I live, holding a handheld ion counter. Ions can be counted. Most certainly you can't see them, you can't hear them, you can't feel them, you can't smell them. You can feel them if you knew they were there, but for the most part, the only way to know ions are in the air you're breathing is simply to measure them. And that's exactly what I'm doing. And what I'm measuring are high concentrations of ionizations at that waterfall caused by something called the Leonard effect. It's L-E-N-A-R-D. Look it up, it's pretty cool. If you take a droplet of water and you break it apart, it will actually impart a charge of negative ionization to the air that surrounds that droplet of water and leave behind in the droplet itself a positive charge. But think of water that breaks apart. Think of waterfalls, for example, cascading water hitting the rocks, breaking apart, but also think of rivers and streams and oceans and rain. And you can imagine the potential that that naturally occurring phenomena has to ionize the air as well. And here's the point. It will ionize it with both positive and negative ionization potentials or electrical charges, therefore bipolar ionization. And where the air is the cleanest and where the ions are emitted to the air through nature is typically where they are in their highest concentrations and where the air is the cleanest. The problem is simply this: as that air works its way inland into more polluted urban environments, such as downtowns, for example, those ions are depleted as their electrical potential is discharged in helping to do certain things to clean the air that we're breathing. In part, that's why nature puts them there, to help make the air cleaner. So by the time they get into an urban area, they've been substantially depleted. And then when you come inside a building that the Environmental Protection Agency will tell us can easily be 5 to 10 times more polluted than the air immediately outside of the building, these natural concentrations of ions are depleted even further. All we do with needlepoint bipolar ionization is impart an artificial charge of ionization, both positive and negative energy potential, to the atoms and molecules in the indoor air to try to bring them up to a level that is more consistent with the ion concentrations outdoors where the air is cleaner. We want to give the indoor air a fighting chance to potentially be as clean as the air outside the building, and more so the air at ocean, where the ocean meets the sand, and at mountaintops where the ion concentrations are considerably elevated. One thing that's very important to understand with regards to any type of advanced electronic air cleaning technology is that you want to make sure that product is validated for zero ozone production. Ozone is O3. Ozone is a toxic gas. Ozone is a respiratory irritant. Ozone is something that is created outdoors on sunny, polluted days. We want to leave it outside. We do not want to install any electronics in the building that can produce ozone. In fact, it's so critical that ASHRAE has said in the Ventilation for Acceptable Indoor Air Quality Standards that we use here in the United States, and perhaps you use there to ventilate your buildings, that you must apply electronic air cleaning products that have been validated to UL, which is Underwriters Laboratory Standard 2998 for zero ozone production. And in fact, based on SAGE and EMG, they caution against using devices that produce ozone. And CIBC has cautioned against using any bipolar ionization unless specific precautions are taken in the product design and maintenance for no ozone and byproducts. This is very important. If you're specifying product, or if you as an owner are installing electronic air cleaning technologies in your building, to be compliant with the recommendations made here by these accredited authorities and agencies, you can go to Underwriters Laboratories website, and under what they call SPOT, S-P-O-T, you can enter the manufacturer's name of the product. And I'm not just talking bipolar ionization or needlepoint bipolar ionization, anything electronic, photocatalytic oxidation, dry hydrogen peroxide, UVC lights, polarized media filtration, electronic air cleaners, anything that's electronic, electric, that plugs in that's an air cleaner should be validated to this UL 2998 zero ozone producing standard. Let's talk a little bit quickly about what ionization can do to clean the air. I told you it does. I will now tell you how it works. As I mentioned, what I am doing with needlepoint bipolar ionization is simply imparting a charge of energy, both positive and negative electricity, to the atoms and molecules in the air that cross over the device, that go out through the ductwork, that go out through the registers and grills and enter the space and mix with the issues of concern, the particles in the air that are there. For a minute, think of a magnet. We know that magnets are polarized. They are either positively or negatively magnetized, right? They have opposite polarities. And what happens when I bring a positive magnet in close proximity to a negative magnet? Clink, they come together, they agglomerate, they become bigger, opposites attract. In similar fashion, these atoms and molecules that I have imparted an electrical potential to, both positive and negative, can go out into the space. They can mix with particles in the space of opposite polarities. And guess what happens? Positive ionization will hit negatively charged particles and clink. Negative ionization will hit positively charged particles and clink. And over time, the very, very small particles that are an issue of concern, that are originated in the space and too small to influence with air motion, become bigger. Clink, 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 clink. They agglomerate, they become bigger, their mass increases, and they are now more transportable with traditional air movement in the space. Think for a minute real quickly of a sailboat sitting out in the middle of the ocean. The mast is up, the sail is down, gale force wind can come along, and all that sailboat's really going to do is rock back and forth. There's just not enough surface area exposed, even to that high velocity wind, to be able to effectively propel it across the water. But what happens the second I open the sail on that sailboat and expose more surface area to that wind? A very gentle breeze can come along and most effectively and efficiently propel that sailboat quickly across the water. That's all we're doing with needlepoint bipolar ionization. We are opening the sail on the very small particles. We are making them bigger. We are exposing more surface area to lower velocity air in the space. That lower velocity air can now transport those particles back to HVAC system filters that before we're never seeing the particles. And because the particles are bigger, filters can be more effective at extracting them from the airstream. It's a pretty simple concept. And in fact, the Illinois Institute of Technology here in the United States did a CADAR, which is a clean air delivery rate study, on a portable Hepa air filtration machine in a non-ionized and an ionized environment. And what they concluded was, based on the particle size, the ionized environment would contribute a 20 to 50% increase in that electronic air cleaner's clean air delivery rate. So in other words, the ionized environment did exactly what I mentioned. It would agglomerate particles and get them back to the filter more efficiently and effectively. And that in space portable Hepa filtration machine, based on particle size, became 20 to 50% more effective at removing particles from the space. It was already efficient. It's a 99.97% efficient Hepa filter, but until I get the particles to that filter, it cannot be effective. And ionization most certainly contributed to getting the particles back to the filter quicker, making them bigger, and making an efficient filter more effective at extracting them from the space. And that's exactly what we're being told needs to be done. We need to be treating the space. As well, though, because I've imparted an energy potential, an electrical potential to the atoms and molecules in the air that go out into the space and work on the particles of concern in the space itself. If there are certain viruses or pathogens in the space that can be inactivated or killed through an electrostatic interaction with the cell surface of that particular pathogen, needlepoint bipolar ionization has been proven to be effective at inactivating and killing certain viruses and pathogens based on certain ion concentrations, certain amounts of time, at a specific rate of reduction. And for example, in the lower right-hand corner, we can see that through third-party testing over a 60-minute period of time, needlepoint bipolar ionization has been effective at inactivating SARS-CoV-2 at a rate of 98.33% over its natural decay. That's important to understand. The virus has a natural decay rate that will inactivate it over time itself. Needlepoint bipolar ionization contributed an additional 98.33% in its inactivation in a 60-minute period of time. So the technology can be effective at doing things like that, as well as agglomerating and removing particles from the space. This is a real crude, if you will, demonstration of what the technology might look like mounted in a real world application. On the left-hand side, I have a space, and that space, of course, has certain issues of concern in the air that we're breathing. On the right-hand side, I show an HVAC system with ductwork and filters, which have been tasked with trying to remove those contaminants of concern from the space. You probably have a heating coil and a cooling coil. Perhaps you have some humidification and things of that nature in that system. And as well, you may have a air cleaning technology such as needlepoint bipolar ionization mounted in the HVAC system itself. And as I mentioned, what we do is impart a charge of energy to the atoms and molecules. We ionize the air that passes over the device and goes out through the HVAC system into the space and begins to mix through air circulation in the space with the contaminants of concern that are there. And we may begin to, for example, inactivate certain viruses that are there. We may begin to kill certain pathogens in the air that are there, such as mold and bacteria and fungi, things of that nature. We may begin to be able to work on eliminating certain VOCs or odors that are in the space. But at the end of the day, as I mentioned, the most profound benefit is that we are simply agglomerating the very small particles over time. We are making them bigger. We are making them more transportable. And watch the filter. I now can get them out of the space once and for all. I can get them back to the filter, where because they are larger, it is easier for the filter to extract them from the air. And we are doing what I mentioned is the most important and profound benefit that we can do in making healthier and more productive indoor environments. We're clearing the sunbeam. We're getting rid of the stuff in the air that we are breathing. And if it isn't there and I can't breathe it, it can't hurt me. It's a relatively simple concept. Actively treating air and surfaces continuously, as the guidance suggests we need to do in the space itself. It's a technology that really, it's clean room technology. It's been around for decades. It's been utilized in industrial clean room applications, semiconductor clean rooms, pharmaceutical, food processing, healthcare type clean room applications. But the technology has now been scaled to be fittable and affordable in more traditional HVAC systems. On the right-hand side, I show a space. It most certainly could be mounted, as mentioned, and done by ITT in their testing, in a portable Hepa filtration machine directly in the space to ionize the air and immediately agglomerate and bring particles back to the Hepa machine more effectively. They make duct-mounted products that can be mounted in the ductwork itself, closer to the space. And as you work your way back in the HVAC system, as shown on the right-hand side of the slide, it can be mounted in furnaces and fan coils, water source heat pumps, window air conditioning units, PTACs, mini split air conditioning systems, variable refrigerant velocity systems. It can be mounted at VAV boxes. It can be mounted in rooftop units and air handling units, even further back in the space, should you want to do that. And there are manufacturers that make product that can handle any size of HVAC system that you may have, that you're working with, or that you would want to apply the product to. And with that, I think I'm on my mark exactly for time. First time, there's a first time for everything. And I will now open it up for questions and comments. I do want to leave you with one quote that I think is very important. And that is simply that the greatest challenge we face today is the failure to adapt to change. And boy, are we going through some changes, right? So thank you.
Amazing. Thank you so much, David. That was such an interesting presentation. Please do, attendees, all put your questions in the Q&A function. We'll now move into the question and answer section of the event. Yeah, it was a really interesting presentation and amazing to hear about this this technique. So for the first question, we've got, how is the efficiency and capacity of plasma for big volume of particles, such as over 35 micrometers per cubic meters in real life, compared to HEPA in a certain period of time?
Okay, I think I kind of understand the question. I'll do the best I can to answer it. Its most profound benefit is in helping to agglomerate the really, really, really small particles. So I think he mentioned 35 micrometers in size. Is that correct? That's pretty big. I might suggest that particles of that size may, through gravitational influence, have a tendency to settle out on their own. Maybe not. And a lot of times the larger particles can be transported by lower air velocities more effectively and get back to filters more effectively. We know filters get dirty, right, in HVAC systems, but what they're typically picking up are the larger size particles that are easier to transport without some type of additional HVAC technology or air cleaning technology to help agglomerate and make them bigger. So the profound benefit of this technology is simply on the really, 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 really small particles. Again, the ones you can't count, the ones you can't see. And over time, what you'll actually see, and it's quite interesting, when you apply this technology to the space, you'll walk in with a handheld particle counter, and it won't happen instantaneously. It's going to take some time for this mixing to occur, but what you'll actually see is an increase in the countable particle sizes. And someone will say to you, you're creating particles. My space is dirtier than it was before. That's not the case. What's happening is the small ones that you can't see and can't count are now large enough to be countable. And what happens then is you'll see that start to trail off as those particles are more effectively removed from the space, and the space overall becomes much cleaner than it was prior to the ionization process. I hope that answered the question.
Oh, that's really interesting. Thank you. And is there any evidence on how long-term use of ionization technology impacts on filter change schedules?
More than likely, what you're going to see are additional filter change requirements, particularly at first. And everybody goes, oh my gosh, I don't want any more maintenance than I already have. Here's the beauty of it, though, if you will. What ionization can do is make a less efficient filter more effective. It can also make a more efficient filter more effective because the particles are getting back to the filter. So let's say, for example, I want to maintain my lower efficiency filter that I've always been using that's relatively inexpensive. Because those particles are going to get back to that filter will be extracting more of those particles. It will get dirtier quicker, and I will need to clean it more often, but it's a less costly filter than going to a higher efficiency filter. Now, I understand there's a little bit of additional cost there, but let's be honest, in the past, it was you and I in the space that was the filter on the small particles. We're walking into that space. We are breathing those particles directly in the space. We no longer are human filters. We're going to allow the HVAC system to do what it is tasked with doing. And if there's a little bit of additional maintenance with regards to that, I hate to say it, but so be it. That's the benefits of cleaning the indoor air more effectively, making the space safer for us as human beings to be occupying that space together. Does that make sense?
That makes a lot of sense. Thank you. And kind of related to that point, and we've got two questions here that are asking about how filters are disposed so effectively to prevent the re-release of filtered particles, and especially when they've been used to target things like airborne viruses.
Sure. So I'm not an expert on filter maintenance, but I can tell you what ASHRAE and ASHRAE here in the United States says. There's a couple things you can do. Number one, wear PPE when you're doing filter change. We always should have been wearing PPE, right? It's just come to the forefront with SARS-CoV-2. A filter maintenance person should probably be wearing gloves. They should probably be wearing goggles. They should probably be wearing an N95 or equivalent mask, perhaps more, right? And then what's suggested, if you want to, you can remove the filters from the HVAC system itself. I have heard that some maintenance companies are actually spraying the filters with a bleach water concentration before they put them into a plastic garbage bag, seal the plastic garbage bag, and dispose of it as waste traditionally in your normal fashion, if you will. That's the only suggestion I can give. And if on top of that you have local or national authorities that are giving you guidance, or you have an owner that has a specific protocol for how they want their filters changed and how they want their personnel protected, follow that most certainly.
Amazing, thank you. And what is the evidence of byproduct formation with ionization technologies? UK scientists worry about the production of formaldehyde and other dangerous VOCs with their use. How safe
Sure.
do you think active technologies like this are?
Well, so there are various methods of creating not only bipolar ionization, but other things such as dry hydrogen peroxide and catalytic oxidation, et cetera, et cetera, et cetera. So I suggest, number one, that if you're considering any of those technologies, you reach out specifically to the manufacturer that you have chosen and ask them for that information. As a manufacturer of needlepoint bipolar ionization, we have byproduct testing that we've done, and we have those reports available to the public. The number one concern on everyone's mind, whether it be ASHRAE or CIBC or any of the other organizations, even the CDC that are providing guidance on these technologies, is ozone. That's a no-no. And for sure, you want to make sure you apply a product that does not create ozone. Ozone will interact with all kinds of things in the indoor environment and create byproducts and help create particles, and are an issue of concern from a standpoint of the occupants in the space breathing it. So, follow the guidance, follow the UL Underwriters Laboratory website, go in and validate any electronic air cleaning product that you are considering applying to the space. All you need to do is jump on their website, go into Spot UL, type in the manufacturer's name, and in front of you should appear pictures and model numbers of the products that they have sent to UL to have tested and validated. If nothing shows up, they're not validated. If their product array shows up, they most certainly are. And I highly recommend you do that. Any electronic air cleaning product whatsoever, anything. That answer it?
That's perfect. Thank you very much. And in terms of kind of making sure an ionization unit is still functioning correctly, apart from just keeping an eye on the on light, would this be done using an ion monitor you spoke of earlier? And if so, what kind of levels would you be looking for?
Sure. So there is an on light on the device itself, typically, at least on the ones I'm familiar with. There is a little green light that comes on. That's not necessarily telling you that it's making ions. It's telling you that it's on. One thing that's really important, regardless of the technology type that you use, is that you keep it clean. If it cakes with dirt, dust over time, its effectiveness will drop, and it will not emit, whether it be ionization or UVC photons or whatever the case might be, it won't emit those at its highest efficiency. So you need to go in over time and wipe those devices off with a rag or whatever the case might be, unless they are auto cleaning. Now, the product that we manufacture is an auto cleaning product, so it keeps the needle tips themselves clean at all times and functioning at its highest efficacy. That is very important. From there are several things you can do. Number one, you can walk into a space that's been ionized with a handheld ion counter and read ion concentrations in the space, or there are duct-mounted ion counters that can be applied, or there are space ion counters that can be applied as well. So you can tell that the space is ionized more highly now than it was perhaps in the past when you turn the device on. As far as ion concentrations, what we typically recommend is that you try to create ion concentrations in the space that are anywhere from 2,000 to 5,000 ions per cubic centimeter higher than they were without the device on. If you walk into a traditional office environment, for example, and I've done this hundreds of times, I can almost guarantee you that you'll see ion concentrations somewhere in the area of 400 positive and 400 negative ions per cubic centimeter when you count them on the handheld particle counter. After I turn the device on and allow the ionization to come into the space, fill the space, flush, and work for a while to remove particles, and then let the ion concentration settle out, I want to try to read somewhere between 2,000 to 5,000 ions per cubic centimeter, both positive and negative. I hope that answers it.
Yeah, that's perfect. Thank you. And does ionization make the agglomerated particles stick to other indoor air surfaces before they are removed by a single extract point?
Great question. The concept behind bipolar ionization is to make sure that we impart a concentration of both positive and negative ionization to the space. That does a couple of things. It allows oppositely charged particles to attract to one another and agglomerate. But what it also does is it takes a surface that may have a certain charge potential, for example, negative, and by interfacing it with positive ionization, it will neutralize that surface charge. So there is a less of a potential for those particles now to plate out onto surfaces, whether it be the wall, the ceiling, the floors, devices, et cetera, et cetera. So actually it contributes to eliminating issues with the plating of particles onto surfaces, because we are maintaining those surfaces at more of a neutral charge potential now due to bipolar ionization.
That makes a lot of sense. Thank you. And I think you covered this in your presentation a little bit, but maybe if you could go into a bit more detail. How does ionization help the particles return to the filter?
Okay, so if you have a very small particle with a very small weight and a very low mass, very low surface area exposed to the air itself, it's very difficult for those air molecules to have an influence on that small particle size, right? That particle actually, the smaller ones through Brownian motion are just going to hang in the space, bouncing around off of other atoms and particles in the air. They're just going to hang there. What happens is by making them bigger, I stabilize them. I expose more surface area to a lower velocity of air that we typically see in more traditional HVAC environments, so that now, because they are larger, that lower air velocity has an easier mechanism to influence their transport through the space. It's what we do in clean rooms, and that is how you make clean rooms really clean. You do a couple of things. Number one, in a clean room, you're not going to see 1 or 2 air changes per hour, or 3 or 4 like you might see in a traditional commercial environment. You may see 30 or 60 or 80 or 100 high air velocities in clean rooms to help propel those small particles more effectively. In clean rooms, you're typically going to use ULPA filtration. That's 99.99997% efficiency, right? And then on top of that, between higher velocities and higher filter efficiencies, many clean rooms will ionize the air to help agglomerate the particles, make them bigger, and make them more quickly and more effectively moved with those higher velocities back to those higher efficiency filters. And in a clean room, you're not going to see, 18 to 20 million particles per cubic foot or 700 million particles per cubic meter. You may see a few particles, per that same volume, right? They're really clean. I'm not suggesting that this technology will make a office, for example, clean room clean, but it's going to push it in that direction quite a bit more effectively than anything else will.
Amazing, thank you. And just the quick question, which is all we got time for now, is how expensive roughly is a single Hepa filter?
A Hepa filter, that's a good question. I'm not a filtration expert. I would assume a single Hepa filtration, a single Hepa filter 24 by 24 would probably run a couple $100 US, right? Compared to a MERV 13 filter, which might run $20 US, compared to a MERV 8 filter, which might run $3 or $4 or $5 US. That'd be my idea if I was going to scale it, something to that nature. Hepa filters are expensive. And, the beauty of needlepoint bipolar ionization is simply that we make less efficient filters more effective. So there's a cost benefit to this, as well as creating a healthier, cleaner indoor environment.
Amazing. Well, thank you so much, David, for your really interesting presentation. It was really great to hear from you today. And thank you so much to all the attendees as well for logging in and engaging in the question and answer bit. It's really great to hear about
That was fun.
Technology. Thank you. I hope everyone found that beneficial and informative. The next IAQM webinar is on the 7th of July, and this is on odor assessment, reflections on the effectiveness of IAQM guidance. And you can register for this on our website. Thank you once again, David. Really great to see you today. And I hope you all have a great rest of your day. Thank you very much.
Cheers.